with some Algebra 1 review. I'm going to graph a line, but this one is not an equal sign, it is an inequality. So I'm going to just review how to graph it. I expect you have done this before. I personally do not care if you change the form, but it is very easy to make silly mistakes when you do extra work that you don't need to. So I'm going to keep it in standard form. If you want to change that into y equals mx plus b, then you should try it and see that you still get the same answer that I got when I didn't change the form. So I'm going to leave this in standard form, and I'm going to find the x and the y intercept, and maybe the slope if I need it. I'm just going to find more information than I need just so you have choices when you do it yourself. So the x-intercept, remember we make y 0, so the ordered pair, something 0. If I make y 0 in that equation, what's x? If I make y 0, what's x? It would be 4. Make y 0, x is 4. And for the y-intercept, I make x 0, then what's y? Negative 4. And you can also think about the x-intercept being c over a. Y-intercept is c over b. The slope formula, if you want to do the slope, it's negative a over b. So what is the slope of this? What's a? So we do negative 1 over b is negative 1. So our slope would be positive 1. How to get what? Wait, where do I get what part of negative 1? Negative 1. Which, the top one? So the formula is negative. So that's where the negative sign came from. And then a. This is standard form, so it's ax plus by equals c. So the a came from what's in front of that x. And the b came from what's in front of that y. Okay, so you don't necessarily need the slope. You just need two pieces of information. We can use both ordered pairs, 4 and negative 4. Or we could use one of those ordered pairs and the slope of 1. Now when you go to connect it, this is what's different. When you go to connect the line, what happens if it is only less than and not less than or equal to? Is what? You're on the right track, but we're not drawing a dot. We're drawing a line. So it's a dashed line. But totally same thought process. This is going to be a dashed line because it's not actually equal. It's going to be a dashed line. And then when we have less than or we have greater than, we're going to be shading, right? You have to figure out which side of the line gets shaded. It's one of the sides. There's two sides, one of the sides. So you can pick any ordered pair you want, and we're going to test that in the equation to figure out what gets shaded. Any ordered pair you want. Let me rephrase that. Any ordered pair that is not on the dashed line. I hear lots of different answers. You can choose whatever you want. I'm going to choose the easiest ordered pair to plug in. In my opinion, 0, 0 would be the easiest one to plug in. I'm going to test the point 0, 0. So that would be 0 minus y less than, 0 minus 0. Question? 0 minus 0 less than 4. So is 0 less than 4? Is this point right here a point that is part of the solution? Is that true? Yes. So if that is true, If that is true, that means that the side that gets shaded contains 0, 0.
Isn't there like a rule that if you divide by a negative,
Yes.
like, so you divide by a negative switches?
The inequality switches. So if you were solving that for y equals, you would have to remember that rule. When you divide by -1, the inequality would switch. That's why I don't like to switch the forms. Yep. All right, our next example, oh, by the way, this is the answer. The answer is every single ordered pair that is graphed and shaded. Every single ordered pair is a solution. So there's no way I'm going to list them all. That's the picture that shows you all the answers. Now, when you have a system of inequalities, you've got more than one, we have to find where the two shading overlaps. So I'm going to find one of them. I'm going to find the second one, but I'm only going to darken and shade in the part where the shading overlaps. So when we do the first shading, please don't color it in super dark. I'm also going to use 2 different colors, which you're more than welcome to do, just so you can follow my work and see the different colors and what goes to what. All right, first one is 2x plus y is greater than 5. I'm going to treat that like equals when I'm solving it. I'm going to find my x-intercept. I'm going to find my y-intercept. I'll find my slope. I only need 2 pieces of information. I'm going to find more just for notes. X-intercept, you make y 0 and solve for x. It is also c over a, so 5 over 2, which is 2.5. And you go to graph it. Y-intercept, make x 0. You can also do c over b, so 5. Oops. I always feel like my graph is not very accurate when I'm using decimals to graph. So finding the slope might be helpful in this case. Negative a over b. So I would do negative 2 over 1, which would be negative 2. But what point am I going to use? I'm not going to use the decimal. I'm going to use the whole number. And I'm going to go down 2 over 1. Down 2 over 1. Whoop, went too far. Will this be a dashed line or a solid line?
Solid.
That one is solid because it is equal to. If it is equal to, you can actually draw the line. It is solid. And then what point could I try to shade 0, 0, test 0, 0? Okay. I should do that backwards. 2, right? It starts with a 2. So is 0 greater than or equal to 5? Is that true or false? And it's false. That means 0, 0 is not part of the answer. So when I go to shade it, 0, 0 is not part of the answer. I'm not going to shade 0, 0. I'm going to shade the other way. But I'm not coloring that in very dark yet. Okay. I'm going to find all my other information. X-intercept. For this one, it's going to be something 0. 2/3. Not a very fun one to graph. Probably not going to use that. my y-intercept. I make x 0, so it will be -2. My slope to negative a over b. -3 over -1, so 3. And then from my y-intercept, I'm going to go up 3 over 1. Will this one be dashed or solid? Why is it dashed?
It's
Not equal to, so it's dashed. And we need to test a point. I'll go ahead and test 0, 0 because it's not on the line. 3 times 0 minus 0 is greater than 2. 0 is greater than 2. What is that? False. So I do not shade 0, 0. That means I got to shade this way. So where do they overlap? Making it super obvious what my answer is. So if you got that one, start graphing the example 3, the first equation in example 3.
That it wasn't if you only test
Well, we shaded the P1, we shaded everything. Your art teachers
so
right, and where do they overlap?
yeah.
Okay, so the very first question is in standard form. I'm going to do that by x and y intercepts. So my x-intercept is something 0. What is that? 6, 0. The y-intercept is 0, 5. So I graph those. And it's really up to me if I want to do the slope also. But I only need 2 points to connect. If you want to do the slope, you can do more. The slope would be -5 over 6, and you go down 5 over 6. But I don't think that helps you. This one might help you, but not much. Dashed or solid? Solid. Solid. Test a point. You get 0 less than equal to 30. Is that true? Yes. So I will shade below this line. All right. I'm not doing it yet because I still have 2 more to do before I really shade the answer. I just kind of gave myself a hint of where it's going to shade. Now for the next one, y is less than 0. No, less than 3 but greater than 0. Y is between 0 and 3. This is actually 2 separate equations. So the first equation is y is greater than or equal to 0. The second equation is that y is less than or equal to 3. So there's two equations, and it's between those two. So when we go to graph them, here's y. I gotta use straight lines, sorry. Bothers me not to. Here's, that's where y is 3. Here's where y is 0. And where will I be shading? In between the two. I will shade in between those eventually. And then x between 0 and 4, that's two equations. That's x is greater than or equal to 0 and x is less than or equal to 4. So I'll go ahead and graph those. Here's where x is 0, here's where x is 4, and it will be in between. So if you need to actually shade them and find where they overlap, please do that. I'm just using my arrows that I've drawn to figure out that they overlap here. Like a pentagon, little five-sided thing there. What do the directions say? So we actually have to find all the vertices of this pentagon. And there are 5 of them. What's one of them? All right, 0, 0. What's another one? 0, 3. What's another one? Nope. What's another one that's obvious? What's that? 4, 0. Okay. The other two, you might think that they hit somewhere, but unless you can prove it, it's just up to how accurately you graphed. So we are going to find the other two intersections a different way. This first one right here, I'll just call it number 1 so we know which one we're talking about. Number 1 right there. That is the intersection between two lines. It's the intersection between my purple line and my blue line. So what we're going to do is we're going to use the purple and the blue equations, and we're going to find the intersection algebraically. The purple equation was 5x plus 6y, and you can just do equals, because we're just trying to find where they cross. We don't have to worry about shading. The less than or greater than was just for shading. So we can just use equals. And then my blue equation is what? Which one? And we're just going to do equals 3. So where do these intersect? How do I find it? Plug y in, right. (12/5) is the x that they intersect on. So if you just looked at it and you thought it was 12/5, I would be really impressed. Anybody? Anybody? So 12/5. And then what is our y? What is it? 3. And that's what we plugged in. So we'll do the same thing again with the other intersection. We're going to find the intersection between the purple line and one of my green lines. So my green line that I'm trying to find the intersection between is when x is 4. So we'll do 20 plus 6y is 30. 6y is 10, so y is 5 thirds. So we have x is 4 and y is 5 thirds. Just highlight these answers so you can find them. So we are taking new stuff and we're applying the stuff that we've already learned how to do. If you're ready to go on to the page, so I know you're ready to go on. If you have questions, let me know. Ready? Not be till Thursday.
Is this on the test?
No. The quiz is only 7-1 and 7-3. So do you know how to do substitution and elimination, basically? And with free word.
How many questions?
I don't like 3. I made up here.
3?
It'll be short. Because the stuff we're doing on, that we're learning you on Thursday is going to take a long time. All right. Shortcut for what? Oh yeah, we're totally learning a shortcut next chapter. When you know what matrices are. If you know matrices, there's not a shortcut for this, but there's a shortcut for solving equations with 3 variables. So you have to know how to do matrices to do it.
So if we look up tonight how to make these, can we do that on Thursday?
No, because I'm quizzing you on do you know how to do substitution and elimination. If you know how to do it, you can certainly use it on your APT. That'd be very helpful. But I'm teaching it like in 2 weeks, so within the next week. You'll be fine. All right. Write an inequality for the shaded region in the figure. I'm going to do this a long way. There are shorter ways to do it than what I'm about to do it. And if you know the shorter way, fine. I'm doing it the long way just in case you come across one that you can't figure out a shorter way of doing it. Okay? I'm going to go back to what we've already reviewed in here in chapter 1. How do you find the equation of a line? What do you need? Slope?
Y-intercept.
How do you find the slope?
Rise over run.
You could do rise over run. So you could count. If you didn't want to count or you weren't sure you're doing it right, you could also do the formula, which I'll write down, which is a longer way than just counting. This is the ordered pair 3, -2, and this is the ordered pair -2, 3. You could, I hope you're just counting rise over run on your own paper. I'm going to do it the long way for fun. 2 minus 3 over 3 minus -2. So -5 over 5, -1. Or you could just count up or count down 5 over 5 and reduce that to -1. So you got your slope. Then once we have our slope, how do we find the equation of the line? What are you saying? I couldn't hear you.
Y equals -x plus 1.
That's the answer. And you did that short way by looking at the picture
Yeah.
and finding your y-intercept.
Yeah.
So what if it hits at a fraction? So that's why I'm showing you the long way, just in case the y-intercept is 1, so we could write it y equals mx plus b and be done. But just in case it hits at a fraction in the future, I just want to show you. Yes. Point slope. So just review, we did this before. Y minus y1 equals m times x minus x1. Who knows, maybe you'll use this on your college entrance test that some of you might be taking.
Is it always going to do with points?
Yeah, you would not be able to find information if you didn't have points.
Why do we need
To find our y-intercept, even though we already know what it is. I was just saying, if your y-intercept is at a fraction, if your y-intercept is at a fraction, how do you know the accuracy of it? So you can have this backup plan. Okay, so we would do, it does not matter which point you choose. It does not matter. I'm just going to choose this one down here. And I got y plus 2 equals my slope -1 times x minus 3. And then subtract 2, we get y equals -x plus 1. So that is the equation of the line. But it's not an equation that makes something shaded. It's an inequality. So we have to figure out if this is less than, or if it is greater than, or if it's less than equal to, or greater than equal to. We have to figure out which sign it is. I'm going to just go ahead and write everything except for this sign on my answer blank. So we have to figure out what sign goes here. Do you think you know what? It's not going to be equal to because it's dashed. Excellent. So it's either less than or greater than. Well, they did highlight, didn't they darken in a point? Well, I don't know if you can tell on yours because it's black and white. Okay, so if I test 0, 0, if I test 0, 0, and I put in 0 for y, and I put in 0 for x, I get 0 on one side and I get 1 on the other. Well, and when you look at the picture, 0, 0 is shaded, so this needs to be true. What would make 0, 1, what would make that true? Less than is going to make it true. So it would be less than. And a lot of you probably know if it's shaded below, then it's less than. Almost all the time it's pretty obvious. Below is less than. Almost all the time, it's not always obvious. Almost all the time. All right, next one is a circle. Do we know the equation of a circle? That the center of the circle is at 0, 0. I gave it to you. The center is at 0, 0. What's the formula? So with the D and the E and the F, that's when there's a translation of some sort. With the D and the E and the F, that has a translation. If there is no shifting, if it's straight in the center, it's just x squared plus x squared plus y squared equals r squared. And what's r? Radius. So what is my radius? So we have x squared plus y squared equals 9. But it's not equal to. I gotta figure out what sign it is. What is a point that is inside the shading that we could plug in here?
0.
Okay, that is inside the shading, so we need to plug in 0 and pick the sign that makes it true. 0 is what to 9? Less than. Is it going to be less than, or is it going to be less than equal to? Why is it going to be equal to? Solid line. So less than or equal to 9. You just have to find the equation that makes that picture. Okay, next one.
So it would be dotted around.
It was just less than, yeah. Okay, they've numbered the equation, so we could just stay organized. 1, 2, 3, 4. Equation 1. It's vertical. So what do we know about vertical equations? What do they start with?
X equals 5.
X, and does it equal?
It's greater than
So with X, and it's 5, where's the shading? The left.
Wait.
This is at X equals 5. But the shading, is it bigger than 5 or less than 5? And then equation 2 is this one right here. That's at y equals 5, but where's the shading? Is it at bigger numbers than 5 or less than 5? I'm going to look at equation 4 next, because it's easier. Equation 4, just highlighted some dots. They weren't like jotted in for you. I just noticed that this is where it passes through, so I can find my slope. Yeah.
I'm sorry, can you explain that to me, how you figure out the slope?
Yeah. So, where, like with this one right here, where is it shaded? So this is where x is 5. So it's shaded where x is 4. And it's shaded where x is 3. And it's shaded anything smaller than 5.
Oh,
Okay. And then same thing with this. This is at 5. And it's shaded where y is 4 and where y is 3. So it's less.
how is that true? Because it's not all shaded.
Right, but we have 4 equations, and the shaded part is only where all 4 of them overlap. So I'm going to draw something, but then erase it because I don't want it there. But if I was talking about this line and I was talking about just that equation, it would be all of that shaded, right? But then it has to overlap with this one shaded. And it has to overlap with the other 2. There's 4 of them there. So this is the region that's made. They're not going to show you all the individual shading. They're going to show you where it overlaps. Okay, so which one are we on? Number 4. Number 4, I just colored in where the dots are so we can find the slope. What's the slope? M is 3. And then what's the y-intercept? Right. So I can write that as y equals mx plus b. Oops, that's number 4. I just put it in the wrong spot. Then I have to figure out the shading. And it actually passes through 0, 0, so I can't use 0, 0 as a reference point. But I can use 1, 1. If I put 1, 1 in here, what makes it true? And it's equal to, right? And also, it is shaded below the line. Okay, and then number 3. So number 3, we have 2 points, but we don't have a y-intercept. So just take off the graph. But you could probably draw your graph and figure it out, but I'll do it the long way. I'll use my point slope form. How do I find the slope for equation 3? So negative 2 over 2. So negative 1. Oops. And I'm going to do point slope form, y minus, I need a point. 5, 3. Y minus 3 equals negative 1 times x minus 5. So y equals 8. So we're going to have y something negative x plus 8. And I have to figure out the sign. I need a point that I can test. Say that again? Yeah, you can do 1, 1 again. You can also do 0, 0, but 1, 1 is fine. So if I put in 1, 1, then I will have, oops, I didn't write my equation over here. I put in 1, 1, I will have 1 something, negative 1 plus 8. So 7. 1 is what to 7? So less than equal to. All right, last one. Can you find the equation of the line on example D? We just did a bunch of examples with lines. Can you find the equation of the line? We'll call that equation 1. Can you find the equation of the line? It's got to be like inequality. So you find your y-intercept is at 2, and your slope is negative 1/3. So I know that. Where is it shaded? Above it. So I could test a point that is above that line, or if I'm catching on it. How about the parabola? There is an x squared in it. And what? So is this a parabola that has a stretch, or is it the parent function parabola with no stretch? That is a no stretch. That means there's nothing in front of x squared. And it is only -2, which affects the y-intercept. So that's the equation. X squared, take away 2. X squared, move it down 2. Is it shaded above it or below it? Above it. So it's greater than or equal to.
I have a question.
So like for these, so if they were all like in the same shaded area, are they all going to be the same size? If they're all in the same shaded
Hey guys, let's see. I think there's another equation even though there's 4 ones. Go back to C real fast. Look at that. I didn't do that accurately. There's something, it's with this one and this one. There's something missing. Because it also stops at 0, 0. It was harder to tell on this one, but here I'm like, we didn't have a border there. So go back to C and fix that. I apologize for that, but it does have to end at some point too. So that is a border too.
Since there wasn't a line right there, we had to do it.
Well, I didn't think about it, but it's kind of like the other one that we did, where this had a stopping and a starting point for the x's. So my x's should have had a starting and a stopping point, and my y's should have had the starting and stopping point. I just wasn't thinking about it when I did it. I'm sorry. It will not be on our quiz. The quiz will only be over the solving part, the systems, not the inequalities, just the regular equations. And you've got time to work on, oh, and I graphed for you. You need 9, and I printed out 12. If you cannot handle having them on front and back, then please come take more. Okay? And if you've already taken some, I see some of you have already started, then let me know so I'll give you a quick round. I think I'm still recording this. Recording it.